Alright, so we will start today with this question. This is the question from matrix. A and B are two n by n matrices such that determinant of A not equal to 0 and A plus B is equal to AB whole square and BAB is A plus I. So we have to see which of the following statements are correct. So first of all, you see the data or the information what we have is this one. The determinant of A non-zero, it guarantees that the A inverse exists. And the other two data or the two information, we will use it. So you notice that the BAB is A plus I we have. And also the second one is A plus B is equal to AB squared. I can write this A plus B, AB squared as AB times AB. Now we also notice that the BAB is now here, we can see. At the place of BAB, I can substitute A plus I. So we will get what? Is A plus B is equal to A times A plus I. And we can multiply this both sides. So I mean not both sides, is A to both of the terms. So we get A squared plus AI, that is A. Now this matrix addition is commutative, so there is no problem. You take A plus B or A square plus A, the A and A we can get cancelled. So we get it A is equal to, not A is equal to, B is equal to A square, or A square is equal to B. A squared is equal to B we got. And this information we are going to use in such cases. So let's see this, the first one. So the A option, what they're saying is it A inverse is equal to A to the power 4 minus I. So how do we get A inverse is equal to A to the power 4 minus I? You notice one thing. From this statement that the A plus B is equal to AB square, what we can write is A plus A squared is equal to A, and B is now A squared. So this will come like this. What I'm going to do is, this B value I'm substituting in this as a square, because this equation is in terms of only A. So if by any chance I get this new result and I have the previous result, so I'm using them to eliminate B and try to construct an equation in terms of A only. So in this way we are successful or not, we will see. So this is A plus A squared, and here A into A square will become A cube, and then power will become A to the power 6. Now if I multiply both sides with the inverse, that will give you A inverse A is I, and this will give you A inverse A square, that will become A only, and this will become A to the power 5. Okay, and once again, if I multiply with A inverse, I will get here A inverse plus I is equal to A to the power 4. And so I'm getting A inverse is equal to A to the power 4 minus I. So the statement 1 is correct. Now we shift to the B statement. What is the B statement they are saying? The statement B is B to the power 5 minus A to the power 5. Is it true that it is A plus B? So let's try to evaluate whether it is correct or not. So we notice that in the previous one only we have established this thing, that A to the power 5 I can write as I plus A. So is it useful? And B to the power 5 I can write, B we can write in terms of A, and then we can move further. So what we can do, let's see. So B I'm going to write is, this is going to be B is a squared to the power 5 minus a to the power 5. A squared is nothing but a to the power 10 minus a to the power 5. And a to the power 5 I can write as I plus a. Or we can take a to the power 5 common from there. So a to the power 5 is out. And I can write here a to the power 5 minus a. Now I can take a to the power 5 minus I from there as a. So that will become a to the power 5 times a. Here I am using this fact that a to the power 5 minus I is a. So a to the power 5 minus I am writing a. So this will become a to the power 6. Now this is our LHS for this part B. If the RHS will come at the same, our work will be over. So this was our LHS. Now what is the RHS? The right hand side is a plus b. But notice the b we have already found, that is a square. So this is going to be a plus a square. Again I can take a common. So I get I plus a or a plus I. But you see that I plus a is again a to the power 5. So this will give you a into a to the power 5, and so it is a to the power 6 again. Therefore option B is also correct. So two options are correct so far. Let's go for the C and see what will happen. Option C is, they're asking whether a to the power 9 is equal to a to the power 4 plus a plus I is or not. So you notice that this is a very crucial information we have collected, and we can use it because you notice that again this a to the power 9 is written in terms of a to the power 4. So somehow we can think that we are reducing the power of a to the power 9. So if you start from the LHS, that I can write a to the power 9 as a to the power 4 into a to the power 5. And already a to the power 5 we have in terms of I plus a in the reduced form. So I can write a to the power 4 I plus a. So I can write again as a to the power 4 plus a to the power 5. But notice again a to the power 5 I can write as I plus a. So that will give you a to the power 4 a plus I. I hope you understood. From there is not so difficult. Now the last part D, the D part, what they are saying is a square b square. So a squared b squared, and we have to show that which is equal to b a square b. Now one common mistake students does, not the mistake but it's a very intuitive thing, they start trying to prove from the LHS to the RHS or the RHS to the LHS. But you also understand why not we can take the LHS and RHS separately. There's a very simple and common mathematical technique. So we can take the LHS and RHS, and you know that the b square is already in terms of a. So why not we can try to write everything in terms of a on the LHS and RHS. So LHS is a squared b squared, and b square we have already established is equal to, sorry, b is already a square here from there. So b square will become a to the power 4. So I can write it here that a square times a to the power 4, and that will give you a to the power 6. And for the RHS, I have again this b a square b, and each b I can replace with a square, again a square, again a square, so that will give you a to the power 6. In this manner we got that all the options correct. Perhaps yes, we got all the options correct. A, B, C, D, all are correct. So let's move to the next question now. Now in this question, there's a question from 3D. I don't know why students sent to me, because it's not so difficult. Perhaps the visualization is not correct. So let me just help how to visualize this thing. So you notice that the line L on the plane 2x plus y minus 3y, 2x plus y minus 3z plus 5 is equal to 0 is a distance 3 unit from the point 1, 2, 3. So first you notice the 1, 2, 3 is actually satisfying this equation. When you substitute x equals to 1, y is equal to 2 and z is equal to 3 in this equation, it will satisfy the right hand side as 0. So it means that this point is on the line only. So suppose I have a plane like this. Let me draw it. So suppose you have a plane like this and the point P is 1, 2, 3 is a 3 unit distant from a given line in the plane. So suppose you have a line also given here inside the plane, which is somewhere here. And there's a point P also here is given in the plane, that is 1, 2, 3. And this plane has the equation 2x plus y minus 3z is equal to 0. Now, the question is a spider starts moving from point A. The point A is not known where it is, so we'll decode where it is. And after moving 4 units along the line, the line is given here. Along this line, the spider is moving. It reaches to the point P. So basically what is happening, somewhere line is there. Let's say the line is like this. And the point A is over here. And from this point, it is moving along the line to reach the point P. But how this line look like, that we have to decode. So notice very interesting fact. What is the normal direction, normal vector of this plane? The 2, 1, minus 3. The normal components are 2, 1, minus 3. And here also they deliberately given 2, 1, minus 3 as the direction vector of the line. It means the line and this line and the normal vector of the plane are parallel. It means this P is on this line itself. If it is not so, then let's check it. Suppose I'm putting x equals to 1 there, that will become 0. X equals to 2 there, that will become 0, and x equal to 3, this will become 0. It means the line along which the spider is moving is perpendicular to this plane. So let me draw the perpendicular. So this is the perpendicular line I drew, and this is the point A from where the spider is starting its movement. This point A, I don't know what the coordinate is. Now it moved, that clearly saying that it moved how much unit? 4 units. So if I just measure this distance becomes 4, that means the AP distance I got, the AP vector magnitude I got 4 unit. I don't need vector will be required. Let's see. Okay. Now what happens that this point P is 3 unit distant from the line, this line L. Let's say this line, okay, not let's say, it's already given that the L is the line. So now I'm going to draw a length unit. So you have to take the minimum distance. So when you take the minimum, it must be perpendicular. Let's say this is the perpendicular distance I have taken. And let me just make it a little. Okay. Let's take this as the perpendicular distance from this, and this length is 3 unit. Now what happens when it hits this C? It reaches to point P, and from P it jumps to line L along the shortest distance. So along the shortest distance, the spider is jumping from here. The jumping doesn't mean that we have to see the jump of the 3D of the jump. We are just seeing that this is along this line, it moves and it reaches there. Let's say this point is, it moves and its point is M. Now, this is the line, by the way, this is not the point L. Okay, now what happens? Jumps to the line L along the shortest distance and then moves 12 unit along the line L to reach the point P. So from M, again it starts moving 12 unit along the line. So I can take this point, let's say the point B, and now this distance is 12. What I have to find out, I have to find out the distance between the point A and the point B. So let's say I join this point A to point B, and it's a picture is a little bit weird, but let's try to visualize it. Otherwise it will be difficult to solve. So let us join this. Okay. Now what will happen? You see, everything is a right angle triangle. So let's join this P and M first. So I'm joining this P and B, by the way. So you notice this is 3, this is 12. So PB, I can find it out. So PB is nothing but the square root of 12 square plus 3 square. That is 144 plus 9, that is root over 153. So PB length we got is root 153. Now we have to find out this AB. So don't you think that this is again right angle here, and this is again making a Pythagoras? So this will give you AB magnitude is what? This length already found. So this is 153 and then 16. Wow, it became 13 actually. So AB length is 13, and what they're asking, okay, if the distance between A and B is lambda, okay, so distance AB is 13 already, so lambda by 2, and they're asking the greatest integer. So lambda is already here 13, so lambda by 2 greatest integer is 6, and that should be the answer. Now let's move to the next question. All right, so let's do this question. This is question from complex number. Let Z1, Z1 bar, Z2, Z2 bar, Z3, Z3 bar, Z4, Z4 bar, and Z5, Z5 bar. There are 10 roots of this equation. The equation is given here. This x to the power 10, 13x minus to the, okay. And we have to find out n is equal to summation goes from 1 to 5, 1 by Zi, okay, magnitude of this and whole square. And then we have to find out the n, and then about the n they have given the sum of digits and all those things. So basically we have to find the n. So I will just find the n and then I will leave it. After that you can find it. So what we can do here is okay, so first we try to convert into the complex number. So we can write this as 13x minus 1 to the power 10 is equal to minus x to the power 10. And then I can leave the minus 1 this side, and I can write 13x minus 1 by x to the power 10 is equal to minus 1. And notice that this is 13x minus 1 is now acting like a z, the complex number to the power 10 is equal to minus 1. So I can write there 13x minus 1 by x is equal to minus 1 to the power 10. So I can write directly 13 minus 1 by x is equal to, and this is going to be e to the power I 2 pi by 10, rather 2 pi k by 10, where k starts from 0 and goes up to 9. So these are the 10 roots of unity, and this roots of unity is equal to 13 minus 1 by x. Now notice one thing, I have to find out the 1 by x actually. So we have already found actually. Wow, because 1 by x I can write 13 minus, and this is e to the power I 2k pi by 10. Now I have to find the magnitude. So basically the zi represents this x, means the place value of x is all the zi's. So if I can see that I have to find out this magnitude, and then further the addition of all the magnitude squares. So what we will do, you know that one thing is very clear, that for any complex number the z bar is equal to mod z squared. So if I use this fact, and let's take this complex number as any u here, and after that we will use how we can use it, but actually here there's a k. So let's say the uk. I mean to say that when k is equal to 0, that will give you the corresponding value at 0 and so on. So what I'm going to do, basically, if to find out, you understood that this x is this, so I can find 1 by x square is nothing but 1 by x into 1 by x. So the idea is this, I'm using the fact that the x is a complex number. Of course, because if okay, so let me just put z there, otherwise it will be confusing for many of the students. So 1 by z square I can write is as 13 minus uk into 13 minus uk conjugate. How I'm writing? Because I'm taking the magnitude of this complex number as well around it, and I'm taking the 1 by mod z square is 1 by z into 1 by z bar. So because I'm using this fact. So from there, what I can write is 13 and 13 is 169 minus 13 times uk plus uk conjugate and plus uk conjugate and uk, that will give you magnitude of uk square. You notice that this uk I have taken here purposefully, so uk magnitude is nothing but 1, because it is e to the power I 2k pi 10, so it can be written as cosine of 2k pi by 10 plus I sine 2k pi by 10, and it doesn't matter what you take the value of k, the magnitude of each of that complex number will become 1, because you are finding the 10th roots of unity. So of course the magnitude of each such root will be 1 actually. So this is 1, so we can write 170 minus 13 times. And also there is a wonderful thing here, uk plus uk bar is nothing but the real part of the uk. You know that the z plus z conjugate is the real part of the same complex number. So now we are actually free with the iota. And what is this actually? 170 minus 13 times real part of uk is cosine 2k pi by 10. Of course, yes. And here I have 1 by z magnitude whole square. I have to give the sum from I is equal to 1 to 10. I is equal to 1 to 10 means k is equal to, sorry, 1 to 5. Okay, 1 to 5. So I have to give this summation up to k is equal to 1 to 5. So what I'm going to do is this one. You notice that the summation k goes from 1 to 5. I'm writing 1 by I should write I, but no problem, because they are taking all these complex numbers as conjugate at this subscript 1 1 2 2 3 3 4 4 and so on, but it will not hinder our calculation, it will not affect our calculation. So I can write here zk, no problem, square, and that will give you summation k goes from 1 to 5, 170. You are adding this thing 5 times 170, and this is 13 times summation k goes from 1 to 5 cosine of 2k pi by 10. All right, what we can do now is this one. By the way, I think this real part of uk I've done mistake. uk plus uk bar is with twice of this, so that should be 26 here. This kind of mistakes. Okay, so now it is fixed. Anyway, conceptually there is no such fallacy. This calculation should be correct. So 170 into 5 I can write here, and that is going to be 26 times summation k goes from 1 to 5 and cosine of 2k pi by 10. Now, what the problem with this thing? The problem with this thing is that we have to just substitute the values of k starting from 1 to 5 and then see what will happen. So you can think in this way also. If I give you the idea to think, I have the all 10 roots of infinity, and so we can write this thing as well in this way. I actually, the two things are coming into my mind at the same time, but let me just go with this. I can write cosine k pi or pi k by 10, and k goes from 1 to 5. So if you want to draw this, all the complex numbers corresponding to this 10 roots of infinity, 10th roots of infinity, 10th roots of infinity, then how these complex numbers look like? Because this total roots are 10, so of course this 2 pi is symmetrically divided into 10 parts. Therefore pi is symmetrically divided into 5 parts. So here I've written 10 by mistake when I divided. So pi is divided into symmetrically divided into 10 parts. So the first is pi by 5. It is somewhere pi by 5 unit here. So pi by 5 is going to be 36 degrees. So 36, again 36, again 36, again 36, and again 36. So we start from here. This is 1, 2, 3, 4, and at the fifth will be here. If I ask you what is the sum of all these, sum of all these means what is the x component of all this, because cosine is the x component. Basically what is happening, you notice that the last value, the cos pi, is going to be -1, and each of them has the x component, that the cos. Means each of this vector has cos 36, again cos 36, again cos 36, again cos 36. I mean increasing cos 36, cos 72, then 108, then 144, and so on. So combinedly all of them, this value, the cos 36 plus cos 72 plus cos 172, 108, and then cos 144, and the last one is cos 180. This must be 0, otherwise this symmetricity will not happen, because you already said that the each complex number had its conjugate. So all the 5 roots are already there and its conjugate is there. So conjugate are always, if you take a complex number here, its conjugate is just the mirror image. So this conjugate is here, this conjugate is here, and this conjugate is here. So in this way we are actually forming all these 5 like 10, and the first one is here. So in that way the 4, 1 and 2, and then 4 are here, 1 2 3 4. This is first, second, and 1 2 3 4, and again it's conjugate 1 2 3 4. So 4 4 8, and then okay. So that should be 0. If you want to calculate, we can. Therefore the answer should be 850. We can also think like this. If you are not convinced with this reasoning that must be 0, let's try to understand in this way. Suppose I have this n, and n is summation k goes from 1 to 5, 1 by zk or whatever, zi square, and this is going to be summation k goes from 1 to 570, no, not 570, 170, and minus 30 into 2, and this summation 2k pi by 10. Now what I'm going to do is I'm multiplying this entire equation by 2. So it will become 2, here will become 2, here will become 2, and here also will become 2. Now this 2 means that we are actually taking this one piece twice, the cosine of 2k pi twice. So suppose you are taking the first value at k is equal to 1, that will give you 2 pi by 10, that is pi by 5. Because you notice that they are not starting with 0 here. I'm deliberately taking this from 0 to convince this is happening, but let's not starting with 0, it's just k starting from 1. So is k starting from 1, that will give you the first root as 2 pi by 10. And its conjugate is also a root. So that root will become that root will become cosine 2 pi. Let me write it. The cosine of 2 pi by 10 plus I sine 2 pi by 10 you're writing. And the conjugate of this is the first root z1. So z1 bar will become cosine 2 pi by 10 minus I sine 2 pi by 10. But notice that we are adding only the real part. So we are taking this 2 times. It means we are just adding all those complex roots starting from 1 to 10. And then we are adding the real parts of it and the imaginary parts of it. Since the resultant of all the roots is 0, the sum of real parts should be also 0 and the sum of imaginary parts should be also 0. Therefore, from this fact, this is 0 at all. And since we have multiplied by 2 here, so n is going to be again the same answer, 850. So in this way, we can do it easily. Otherwise, we have to break our head in other such methods. Now let's jump to the next question, which is the very important and interesting one. And that question is again from complex number. Okay, so in this question, they have given a regular heptagon. And question says they consider regular heptagon A1, A2, A3, A4, A5, A6, and A7 inscribed in a unit circle. And P1 is the product of A1, A2, A1, A3, A1, A4, A1, A5, A1, A6, A1, A7. And P2 is again, P3 is again the sum. Okay, so please read the question and give a try. Then you will see the solution. So the thing is that the P1 is what? Let me write in a different way. So P1 I'm writing is A1, A2, A1, A3, so the idea is I'm writing in a different way just to give a very smart solution for that. I will try to give you 2 different solutions, one from complex number and one from trigonometry, because I have actually created a video on this kind of question before as well, which was asked in JEE Advanced. So P3 I'm writing from here. All right, so we have this situation, and why I have written in this way, you'll come to know. So the idea is that what the question is asking, that the P1 is the product of these all chords we are drawing from one vertex A1. So all the chords means all connecting chords. So it is A1, A2. This is the very one chord here. And A1, A3, then A1, A4, then A1, A5, then A1, A6, and then A1, A7. So this is the product of all the lengths of chord, that's a P1. But when we are deciding P2, we are just taking starting from A2 and A2, A3, A4, A2, A4, A4, A2, A5, A2, A6, A2, A7, and so on. Notice that in this decision of P2, we are just missing A1, A2 because we are finding out the lengths of all the chords starting from A2, but we are not counting what has already previously happened. Previously happened. So this is going to be A1, A2, if I just collect or insert there, this is again asking the product of each chord starting from A2. This is the product of each chord starting from A1. So you notice this heptagon is so symmetrical, it doesn't matter from where you start. If you start finding the length of each chord from A1, that will be the same as if you find out the lengths of each chord starting from A2. So if I embed here A1, A2 again, it is actually the lengths or product of lengths of each chord starting from A2, and this is the product of the lengths of chord starting from A1. So the product comes out here, whatever it comes out, that will be the same as when we just insert their A2, A1 and then find out the product. So whatever terms is missing there, we can insert and just say that they are same as the first P1. But when we are inserting, we are doing some kind of disturbance to our final calculation. And what we are doing, that we are actually finding, let's say the total product we have to find, that the P1, P2, P3 up to P6, this is the total product. It means they're asking only this much product. But we have just inserted for our convenience, so we found that after insertion means after inserting that thing, after inserting, we found the P square. And when we find the P square, we take the root, we get the value P. I think you understood the idea. So our aim is to find only one P1. And we say that the P2 is the same, P3 is the same, but we just multiply P1 7 times. We'll do 7 times. Why? Because here you notice that this is going to be 6 items, here 5 items. To complete this thing, I have to cut from here this whole terms and I'm inserting it here. Because this is A6, A7 and we are missing all those A6, A7. And we are doing, it's like we are taking this whole thing and we are just rotating it like ulta and then fit it into this. So of course this will P1 will come here as one column, then only it can be inserted. So basically we are multiplying this 7 times and then we are taking the square root. So let's find out the first row what we are getting. So the this vertices can indicate different complex numbers. So let's say that I have this complex number Z1 also, we can say. Let's say this is Z2, Z3, Z4, Z5, Z6, and Z7. Let us consider that these are the seventh roots of unity, in which the first term is 1, means first root is 1. So it's not difficult. I can say that if this sum of roots are unity, sum of roots of this seventh roots of unity is 0. So I can simply call it 1 plus z squared plus z to the power 3, 4, 5 and 6, because starting from 1 that should be 0. Now this term I can write also as 1 plus z squared z cubed dot till z to the power 6. This is GP. I can write z to the power 7 minus 1 by z minus 1, which can be further. I can write, suppose z1, z2, z3 all are the roots. So I am starting with the first term as 1. So this z minus 1 I have already taken here. So I can write z minus z2, z minus z3, z minus z4, z minus z5. There's a bracket by the way. And z minus z6 and z minus 1 2 3 4 5 6 Z7. So these are the roots actually. Basically it's actually if this is Z1 here, I'm calling it 1, this is 2, so that will become Z7. If I'm starting from Z0, then this will become Z1. So please understand this thing. And why I'm doing so? Because I need to substitute there. Now you substitute Z is equal to 1 everywhere. So it will become 7, this left hand side. And the right hand side, I'm putting there 1. So 1 Z2. And I'm taking mod also, just to convince that this product will become 7. So this is actually the distance starting from A1 we are taking when we have taken A1 as position 1. It means I can rotate it and again I can take the Z2 as the position 1 and the same result will happen. So the product of all the chords emerging from each vertex is 7 actually. So this P1 must be 7. And you notice the P2 after inserting this A1, A2, that will become again 7. So this is 7, 7, 7, 7, 7. So take 6 times, that P square will not come because there's something missing here. That's why we are adding one more time to get this whole square completed. So P square will become 7 to the power 7. So P will become 7 to the power 7 by 2. What they're asking, that is 7 to the power K. So K should be 7 by 2. 7 by 2 numerical value, I don't know. So 7 by 2 I'm getting. Okay, anyway. Now we'll try to do this question again with the help of trigonometry. So trigonometry, how does it help? Let's try. In this, I don't have to do this like a lot of calculation. I mean, here also we didn't do it, but let me just copy these things just to convince. For that, we have to recall one formula or the result in trigonometry. What that result is this one. If I have summation K goes from 1 to n minus 1, sine of K pi by n, that result is always n by 2 to the power n minus 1. You notice what I did here. This is K goes from 1 to n minus 1, sine K, sine to the power, sine of K to the power pi by n. Sorry, not power, K pi by n is equal to n to the power n minus 1. If you want how it came, you just give me comment in the comment box. I will create a video how it came from the complex number. So to derive this thing again, complex number will use, but if you are such sincere student, you might have encountered this thing, or if not, then please remember this formula. It's very useful. So basically in this whole scenario, we have to find out the length of the chord. So let's try to find out the length of the chord by using trigonometry. So if I drop the perpendicular here, and if I just join this thing, and this angle is the theta by 2, whatever this total angle was there. So that angle was 2 pi by 7 in our case, so theta by 2, but doesn't matter what is there. And if you just try to find out this theta by 2, and you get to understand that this, if you find A1, A3, if in this case, in this chord you are going to find, again you did draw perpendicular, that theta by 2 will be twice of, will be actually multiplied by 2, because again, see what is happening. This angle is already theta, and you are adding again theta here to get to the A3. So this theta by 2 is used to find out this chord. So again, this twice of that theta by 2 will be used there. So in each time the theta by 2 is added by theta by 2. So this is the scenario. So what is the length of this chord? It is easy to understand. This is going to be sine of, because this length is already 1. So sine of theta by 2, and is twice of it. So length of chord starting from AI to AJ is going to be sine of 2 times sine theta by 2. Now the thing is that suppose you want to find A1, A2, that will become 2 sine theta by 2. What about the A1, A3? It will become 2 times sine of 2 theta by 2. So each of them, you can just write it this, let me just write it. It will become 2 sine theta by 2. Then it will become 2 sine 2 theta by 2. Then this will become 2 sine 3 theta by 2. Then 4 theta by 2. Then 5 theta by 2. And then 6 theta by 2. Because there are 6 terms. So you are actually doing the same product. By the way, here I have written the summation. That's the mistake here. Sorry for that. This is the product here. So in this way, this entire thing, you can see that theta by 2, then 2 theta by 2, and you are going up to here only. It means that you are actually making whole revolution. It means there are 6 terms, so you are going up to the 6 here. Means k is going starting from 1 and going up to n minus 1. So that value should be 7 by 2 to the power 6. Because 2 to the power n minus 1. And you have already multiplied there 2, 6 times. So there is also 2 to the power 6 here. So 2 to the power 2 to the power 6 cancel. So again you are getting this 7. And by the same logic, you can create this is again 7, and p square is 7 to the power 7. So that's all for today's video. If you want the proof of this mathematical result, you can just give me a comment. I will create a separate video on that. So that's all for today. See you in the next video with some other problem, maybe GTA or some other sources. Till then, stay math active.